Okay guys, now we're going to look and just take a look at acceleration and what acceleration is. Now previously we've already talked about a velocity versus time graph and looking at the slope and finding the acceleration that way. This is just a screenshot from the star chart that we have, and we can look and we see we have obviously the first two are solving for acceleration. We see that there, and I've added the third one in because we do have acceleration there as well. But just looking on our formula chart and seeing where we have acceleration, making sure that we know that. The other important thing that we need to know about it is all acceleration is acceleration is the measure of the change in velocity all over time. It's the speeding up or slowing down of that velocity that's going to give us either a positive or negative acceleration. So if we're speeding up, we see that we're going to have a positive acceleration because our final velocity is going to be greater than our initial velocity. And so therefore, when we look at our equations, we're going to have a positive acceleration. Now, if the opposite of that happens, if we have an initial velocity that is greater than our final velocity, then we've slowed down, and that would be a negative acceleration. Looking at our equations, main things that we need to know is just how to solve for everything. Looking at this, we see we have our acceleration equals our final velocity minus our initial velocity all over the change in time. Okay, when we're looking at this, we have to be able to solve for every single variable. One of the things that can be challenging is just rearranging everything. The first thing that we need to understand is that when we're looking at this and we have the denominator right here, one quick trick, if we're solving for the change in time, all we have to do is we have to switch acceleration and change in time. So we would see the solving for change in time, all we have to do is get our final velocity minus our initial velocity all over our acceleration. Okay. Another way that we can do it, if we're solving for either one of the variables, either final velocity or initial velocity, the first thing that we have to do is multiply acceleration and the change in time. And so we'd have acceleration times the change in time equals our final velocity minus our initial velocity. Okay, that's the beginning of it, and then all we have to do is solve and bring to the other side either final velocity if we're solving for initial velocity or initial velocity if we're solving for final velocity. Other tricks that we can have is looking at our other acceleration equation. We see that we have our acceleration equals our final velocity squared minus our initial velocity squared all over 2 times the change in displacement. When we're looking at that, main thing that we have to think of here is we can do the same thing. So if we want to solve for delta D, we can switch places with our acceleration. But when we're looking at it, if we're solving for our final velocity or initial velocity, we still multiply these two variables. So we have acceleration times 2 delta D equals our final velocity squared minus our initial velocity squared. The main places where people screw up using this equation is, say we're solving for our final velocity. Okay, we bring our initial velocity over by adding initial velocity squared to both sides. So what we'll have is we'll have our initial velocity squared plus and this is 2 times our acceleration times delta D equals our final velocity squared. And the majority of the time when people mess up, they mess up there because they don't remember that we don't want to solve for final velocity squared, we want to solve for final velocity. And everybody forgets to make sure to take the square root of it, take the square root of both sides, and we see that we get final velocity. Main places where people mess up on acceleration.